Okay, so now we're going to talk about reducing agents and oxidizing agents. And this is where it can get a little tricky because if you're something that is being oxidized, you're actually going to be the reducing agent. And if you're being reduced, you're going to be the oxidizing agent. So I'm going to write this down. The reducing agent is the one doing the reducing, so it's donating electrons. So I'll write it here for my visual people. Reducing agent equals the one that is donating electrons. So if you think of it this way, if you're donating electrons, you're losing your negativity, right? So that means we're losing electrons. So if you can figure out what is being oxidized and what is being reduced, then you can then clarify which one is the reducing agent and the oxidizing agent. So if I'm a reducing agent and I am donating my electrons or losing my electrons, I am the one being oxidized. So I will write one being oxidized. So if you can figure out which one's being oxidized and which one's being reduced, just remember the one being oxidized is the reducing agent. And then when we have the oxidizing agent, oxidizing agent is the one that is accepting electrons. And Alexa keeps thinking I'm saying her name, not electrons. Okay, so if I am the one doing the oxidizing, I'm accepting those electrons. So if I'm accepting electrons, that means I'm gaining them. And if I'm gaining them, my oxidation number is being reduced. Okay, so whatever the oxidizing agent is the one being reduced. Okay? Again, if you can figure out who these two people are in your chemical reaction, then you will know who the agents are. So I will do an example. Now, in order to do these, you guys remember how chemistry builds on itself? We can't learn something and then just totally brain fart it and let it go. You have to retain all that information. So we are going to review oxidation rules really quickly. So if you guys remember, group 1 was +1, group 2 is +2, oxygen is -2, group 17 for the most part is going to be -1. If you have a monatomic element, one that's standing by itself, or a diatomic one, both of those are going to be 0. So that should help you figure out the oxidation numbers, because you have to know their oxidation numbers in order to figure out who's being oxidized and who's being reduced. So first one I'll do is HCl, so hydrochloric acid plus water, and that is a reaction that can go forward and back, creates hydronium. You guys learned about that on our acid and base section, and chlorine with a -1 charge. So the question is this a redox reaction? Now, when you have a redox reaction, the reduction and the oxidation happens simultaneously. You can't have one without the other. One thing can't be oxidized. Those electrons have to go somewhere. So if somebody is donating their electrons, somebody has to be receiving them. And that's why both of these things are going to be happening simultaneously in a chemical reaction. So I'm going to go through and I'm going to assign oxidation numbers to each of these elements to see if they change as we go from the reactant side to the product side. So hydrogen +1, chlorine -1. Okay, that's just based on my, my rules. Hydrogen is still +1. Don't worry about this here. Don't try to multiply those yet. You only do that when you check to see if the overall thing is neutral. And oxygen is -2. Hydrogen is still +1. Oxygen is still -2. And chlorine is still chloride is still -1. Okay, so are we seeing any changes? Hydrogen to hydrogen still +1, chlorine to chlorine still -1. We can check either one of these hydrogens because one of them could be oxidized or reduced. Both of those are still +1, and both our oxygens are -2. So this was just a refresher to show you guys how to use your oxidation rules in order to figure out what's being oxidized and what's being reduced. For this one, since there's no exchange of electrons changing oxidation numbers, then we say not a redox reaction. Okay, so instead of having to say oxidation reduction reaction, they shortened it to a redox reaction. Much easier to say. All right, let's do another one, and I promise this one will actually be a redox reaction, because it would be kind of boring if it wasn't. All right, so we have KClO3 becoming potassium chloride and oxygen. Okay, so we know potassium is in group 1, so that's +1. We have a rule for oxygen is -2. Now this is where you have to do the math. We have +1 and you have -2 times 3 is 6. So oxygen is contributing -6. This potassium +1 brings us to -5. The whole thing is neutral, so that must mean that chlorine is +5. And I know chlorine is in group 17, and that's why I said most of the time it's -1, not all the time. Because again, chemistry, we always have to have our exceptions. And then potassium is +1 and chlorine is -1. They balance each other out. And then O2 is going to be 0 because it's a diatomic element. Okay? So, our molecule, I should say. So your thing is 0. Okay? So let's look. Potassium goes from +1 to +1. Nothing is happening there. We have chlorine going from +5 to -1. So what I'm going to do is I'm going to draw a little bar that connects these guys. Okay. If we were in class, I would say, how do you get from +5 to -1? You subtract 6. And then for oxygen, we have -2 to 0. How do we get from -2 to 0? I'll do it up here. So there's a little bit of difference. -2 to 0, we add 2. Okay? So if our oxidation numbers are changing by -6, this means that this guy is gaining a bunch of electrons. So this is chlorine is the one that is being reduced. Okay? And that's because the difference is going down. We went from a +5 all the way down to a -1. It's being reduced by 6 electrons. Okay? And then we have our oxygen is going from having 2 extra electrons to no extra electrons. Okay? So he's the one that is giving his electrons. He's losing electrons, becoming more positive. So he is the one that is being oxidized. Okay? Now, if I were to ask you, what is the reducing agent and what is the oxidizing agent? All right, so if he's being reduced, that means it's the oxidizing agent. Okay, and then this one that is being oxidized is the reducing agent. Okay, the one doing the reducing, he's donating his electrons, becoming oxidized. This one is gaining electrons, becoming reduced. Okay, so again, as long as you can figure out the difference between these two, which one's being reduced and oxidized, you're able to figure out which of the agents they are. Okay, let's do one more of these. We have sodium and 2 water molecules becoming sodium hydroxide, oopsie, and hydrogen. Okay, so using our oxidation rules, sodium is by itself, So that is going to be, I'll do it up at top again, 0. Hydrogen is +1. Oxygen is -2. Sodium in this one is +1, -2, +1. They balance out. And then H2 is going to be 0 because it's diatomic. Okay? Really hoping you guys can see this. All right, so let's look. So sodium is going from no oxidation number at all to +1. So to go from 0 to +1, that one's easy, +1, okay? So we are losing 1 electron. And then let's see, hydrogen goes from +1 to +1 here, and then +1 to 0 there, okay? So with hydrogen, a lot of times you have to check if you have two things that have hydrogen in them, one might not be involved in the redox reaction, the other might. So this one is going from +1 to 0, okay? So if we're going from +1 to 0, we're going down by -1, okay? So that means that one is accepting electrons. So sodium is +1, and then hydrogen is -1, okay? So since sodium is losing electrons, oxidation is losing, or Leo, lose electrons, oxidized. It's being oxidized, thus making it the reducing agent. And then hydrogen is gaining electrons, lowering its oxidation number, so it's being reduced. And if it's being reduced, it is the oxidizing agent. Okay? All right. Now on to the final topic that was in this PowerPoint. Is going to be balancing redox reactions. Now I know you guys loved balancing these before. This one has some added steps that might make it a little bit easier. So what I'm going to do, I'm going to write the equation and we are going to follow the steps. And then you guys will also, I'm trying not to write the actual answer. You guys will be getting a worksheet probably Monday. Not probably, definitely Monday, to work on balancing these yourself. So it will behoove you to pay attention to this. All right, so here is our reaction, okay? HCl plus HNO3 plus HOCl plus NO plus H2O. So step 1, we need to assign oxidation numbers to all of our elements involved, okay? So hydrogen is in group 1, so it's going to be +1. Chlorine is -1 to balance that out. And the next one, hydrogen is +1. Nitrogen doesn't have a set rule, so we're going to jump to oxygen. Oxygen is always -2. Now, if you look at this, -2 times 3 equals -6. Then you add the hydrogens 1, and that gives us an overall -5. This whole thing is neutral, so nitrogen must be +5. Okay? Again, this should be reviewed, but if that trips you up, please let me know, because if that's confusing, then the rest of this will not make sense. So hydrogen +1, oxygen is -2, chlorine, we don't have a set rule, but if we want to make this whole thing neutral, +1 -2, we're still at -1, okay? So to get from -1 to 0, chlorine must be +1, okay? And then for N and O, we know oxygen is -2 from our rules, so nitrogen must be +2. And then for H2O, you have +1 and -2. Okay? All right, so now we need to figure out who changed. So let's look. We have hydrogen All my hydrogens are +1s, okay? So none of them are changing. Now let's look at chlorine. Chlorine goes from -1 here and +1 over here. So I'm going to draw my little bar, and to go from -1 to +1 is +2. So that means that chlorine is losing 2 electrons. Okay, it's losing, it's being oxidized. But we're not worried about that right now. We're literally just trying to balance it. Okay, next one. We already checked our hydrogens. Let's look at nitrogen. Nitrogen is going from +5 to +2. So if we go +5 to +2, that means we are gaining 3 electrons. So -3, so that one is being reduced. And then this is our only redox reaction happening here. You could have multiple ones, but this is the only one happening. Oxygen is -2, -2, -2, -2. So we're good. So our chlorine is being oxidized by 2, and our nitrogen is being reduced by 3. Now, once we assign the change in the oxidation number, we're going to multiply them by each other so they're equal. So how can we have 2 and 3 be equal to one another? You can make them both 6. So this one I'm going to multiply by 3, and the 3 I'm going to multiply by 2. Just like that. Now, whatever I multiplied by, where these brackets are attached, that number that you multiplied by must go out front. Don't just put it with the chlorine. It has to go, because these are attached. This is hydrochloric acid. We have not separated these two. So that 3 will go out front. So 3 HCl, and then it's also attached to this HOCl. So the 3 will go out in front there. And now up here, we multiplied by 2. So whatever this bracket is attached to must get a 2 out front. So 2 and 2. Okay? So our final reaction, balanced chemical equation, would be this. And the way we solve that is by looking at the redox reaction that is occurring here. Now this one happens to be balanced just by doing these multiplications here. There will be some that are not balanced quite yet. So then you would just do that conventional way that we did before, where you would list the elements, how many they have, list the elements, how many there are, and get them to balance, okay? That's what it means by that final step of doing the like check it method or something like that. That's what that means. So then from here, you would just do the way that you guys had learned prior. But thankfully, this one is already balanced using these steps. Again, I will be giving you guys a practice worksheet to do that, and I will be making a video for the answers for those as well. But that is the end of the material from section 17A. So hopefully this video helped you guys understand better than just staring at a PowerPoint. And I didn't want to have to write all this on the PowerPoint. So that's why I made a separate video. And you guys will be assigned 17A questions on Friday. And then Monday we'll do the balancing worksheet and take some sort of assessment a little bit later, and then you guys will be done.